So far we've talked about the ionic compounds that are made from alkali and alkaline earth metals. And the naming was pretty straightforward, and when we talk about the majority of the metals on the table, so now we're going to start talking about the transition metals, the naming is very similar. The only difference is that these metals, the transition metals, can have a variety of different charges. And why does it matter if the iron, for example, has a +2 charge instead of a +3 charge? Well, to see why it matters, let's look at two of these compounds. So these are images of two different iron oxide compounds. So the one on the left is iron 2 oxide and has the formula FeO. And the compound on the right is also an iron oxide, and it has the formula Fe2O3. Okay, so if we go by our old naming rules, the ones we use for the alkaline earth metals, this is iron oxide, and this is iron oxide. They both have a metal and a non-metal, so we know they're ionic. But how can we tell them apart? It's clear that if we look at them, this iron oxide is black, and this iron oxide is red. So when we name these, we actually have to add in something. And this is the charge that is on the metal ion. So if we look at the first one, this is known as iron 2 oxide, and the one on the right is known as iron 3 oxide. So what we are doing is using Roman numerals to indicate the charge on the metal ion. This iron 2 oxide consists of one iron 2 ion. So iron 2 is an iron ion with a +2 charge. Remember, since it's a metal, it must be positive. And an iron 3 oxide, this compound consists of two iron ions, both with a +3 charge. So you have iron +3. Now let's practice with a few examples of how to write the formulas from the names of a transition metal ionic compound. So we'll start with copper 2 chloride. So to start, we know it's a transition metal, one because it's copper, and we know that copper is in the transition metal section of the periodic table, but they give us this Roman numeral. The Roman numerals, to remind you, I'll list them 1 through 10, are the following. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the Roman numerals that you're going to see. So the first one's copper 2 chloride. How do we figure out its formula? So like we did with the group 1 and 2 ionic compounds, we're going to write the names of the ions. So the copper ion is going to be Cu, and the charge, they tell you the Roman numeral is the charge. So the charge on this will be +2. And the chloride ion, the charge we know because we look on the periodic table, we see it's in group 17, so it has a -1 charge. We can then do the multiple, lowest common multiple check that we do, and we'll see that the lowest common multiple of -1 and 2 is 2, so our compound ends up being CuCl2. Let's try another example, this time using manganese 4 oxide. So manganese 4 oxide. We again write the ion. So our first ion is manganese, Mn, and it has, as this shows, a +4 charge. Metal charges are always positive. And then we have oxide. Oxygen's -2, as is shown on the periodic table. It's in group 16. We do the least common multiples. So +4, -2, -4. 4 is our common multiple. So we have 1 manganese ion, and we have 2 oxide ions. So MnO2 would be our formula for manganese 4 oxide. If instead I had manganese 2 oxide, I would have Mn plus 2. I would have a +2 charge on my manganese. The oxide is still -2. Least common multiple, well, same right away, so we only need 1 manganese and 1 oxide to give us manganese 2 oxide. So you can see how even though we have the same elements in our compound, because they have different charges, here's manganese 4 oxide, here's manganese 2 oxide, we actually have different compounds.